Good day, guys. All you prospectors in the southern part of Australia are probably freezing your proverbials off, but yeah, in Ballarat it's damn cold. It's not the actual temperature. It's if you go outside, it's the wind. The wind just is, I don't know, something about it. I've been on top of mountains before and it's been windy, but it's not like this, even if it's minus, 2 or 3, whatever. Even here, it can be +3, and it's yeah, it just feels colder. Something about the place. Anyway, I had a few custom jobs come in, and thought that might as well do a bit of a show and tell, because there's one in particular that I was sort of thinking, can it be done on, oh God, it was a big job. It was actually on an old SD2000. And the swing now, I'm finding everyone's run around with their little fly speck detectors, picking up all the fly specks, as you do. And there's two ways of thinking about this. How many fly specks do you need to make an ounce? And how long does it take? And how much junk do you dig? So it is I don't know, it's a productivity thing, isn't it? It's how much work you put in and what return you get. But anyway, there's a few people now starting to wake up. And I keep getting these big, deep gold modification requests. And the best detectors to do it to is the older ones, believe it or not. This 2000 here is an absolute doozy. This has got a very low frequency installed, and it also has the whole front end removed, even though the front end in these is by 1980 standards, well, 1990 we'll call it. But basically it was all based on a, what was it called again? God, I can't think of the number of the chip. Jesus. Anyway, it's a dual transistor thing. Yeah, LM393 or something. LM394, 394, whatever it was. They're all covered in white paint, so I don't read them as I remove them. So let's go into the collection. I can hear some, hope no one's coming around. I can hear doors clicking and things. Maybe not. So yeah, LM394. Very, very old dual transistor. Very, very, well, not very low noise, but low noise enough, but a very high beta, very high gain. Somewhere around about, what was it? Could be 500-600 or something. And basically you blow on it and it'll have an effect, but because it's two in the one package on a probably, dare I say, maybe it's a beryllia substrate, poison. Maybe it's not beryllia, it might be some sort of alumina ceramic, but back in those days they used a lot of beryllium oxide in their high power, or anything need high conductivity, especially between, if you've got two transistors and you want the thermal characteristics, and so they're not going like this, oh, I'll catch up to you. You want it doing this so you don't get any noise. And they use beryllium oxide. So do not break open old semiconductors. And if it's got a wafer in there of white material and it's brittle, do not cut powder, or otherwise it's carcinogenic, and it will probably eventually kill you if you do that. They're quite safe as long as they're all together. Why am I talking about that? Because it's just part and parcel. I'm just telling you about the device that's in there. If you want to do this yourself, don't break open the devices, because you might be in for a nasty, rude shock. Especially, you'll find beryllium oxide heat pads on radio frequency transistors, high power transmitter stages. You see a transistor, it looks like a helicopter with different configurations, of course. Some are 6 legs, some are 4, but they all normally have a white ceramic cap. Heard Zachary yell out hello. So I don't know what that is. Could be someone coming around, don't know. So if the door opens, someone barges in, we'll know. As long as it's not Big Mac. Yeah, don't like Big Mac. Quarter pounder's all right, but the Big Mac. David will understand that. But anyway, that's a joke for David. Yeah. I'm just listening out there. So I don't know. Someone may have come around. Don't know. Yeah, anyway, I was just saying on these devices, on the old power transistors, they're usually gold-plated legs. Not always, but sometimes. Used to be. And they get a white ceramic cap on top. And then you got the... and if you lift that off, you'll see all the circuitry, all the transistor junctions and little hair wires and stuff. And what that sits on is beryllium and beryllium oxide, and it's compressed and sintered into a puck. It's very, very good at conducting heat, but it's extremely poisonous. So you wouldn't want to grind that up and have it turn into a dust and inhale even one particle of it. It is deadly carcinogenic. So just be aware, not all electronics is friendly. Even some of the old transformers, even the small audio transformers, that some of them back in the 1920s and onwards were oil filled, and also high power transmission transformers, and also I found them on power conversion equipment out of the 60s, 70s and 80s. They've got a particular oil in there for cooling, and don't touch it. It is carcinogenic. And I remember, I'll tell you how I know this. Many, many, many years ago, one of the transformers on one of the power poles in a street somewhere, someone shot it, right, with a high caliber rifle because it was buzzing and causing interference on their TV set. They knew what it was, and this person rung up the, it would have been the SEC at the time, I would say, State Electrical or Electric Commission, whatever it was called, or State Energy. Well, no, SEC, what was it? State, was it Energy? Or Electricity? Electrical? Whatever it was. It was called the SEC anyway, years and years and years ago. And yeah, this guy had interference on his TV set, and he tracked it down to this transformer. He rang up and complained about it, and they took no notice and didn't care less. So yeah, well, someone shot it with a high caliber rifle and let all the oil drain out of it, and this is really bad, isn't it? I know of it. I wasn't involved, thank God, because I wouldn't do anything so damn crazy. And what happened? The same. God, I better not say the same person. Well, someone called the SEC and said, "Oh, one of your transformers is, basically peeing out oil everywhere." I'd never heard of a transformer being replaced so quickly in my life. Anyway, the transformer was replaced. Lucky it didn't blow up, actually, come to think of it. And yeah, it was a big oil cleanup. And yeah, the talk of the town at the time was that oil is carcinogenic. So I think they've all got good oil in them now. I don't really know. I'm just guessing. This is just an opinion piece, isn't it? And yeah, the fellow involved had perfectly watchable TV after that. Yeah, sometimes you can hear that. If you have radio equipment and even metal detectors, because they do operate round those lower frequencies, especially PIs, broadband things, pick up everything. If you've got any sort of power lines, especially the higher voltage ones, 20, 22 kV, 2200 volt. What else is there out there? I don't know. 240 itself, possibly, yeah, a lot of the top wires are all 2200. And yeah, anything, single wire earth returns, that's, I think, 22,000 or something that go across farmers' paddocks. Don't touch those. Don't come into contact. You'll be, crispied. But yeah, all that stuff makes noise, and you can hear it sometimes if you get close to the poles with the insulators, and it is damp or foggy. Not so much the water vapor causes conductive paths, but what happens is a lot of dust in the atmosphere settles on the insulators, and if it gets moisture, it starts to become a little bit conductive. It might have mineral salts in the makeup of the dust, and it wants to partially conduct. And yeah, it'll arc, and it will upset everything around for miles if it's operating on low frequencies, and the harmonics thereof just travel up and yeah, all the way into up 100 megahertz, 200 megahertz. It just can be heard very easy. Not usually on something that's an FM radio, but anything that relies on amplitude modulation, such as aircraft, would you believe? Aircraft use AM transmitters and receivers still. I don't know. It should have been changed years ago, but it hasn't. Yeah, well, maybe it has changed. I haven't looked for many, many years, but it used to be all AM stuff. And yeah, it does interfere. Anyway, what I was saying about this detector here, this is like total overkill, but the guy wanted it total overkill. It has a input stage that's in there. The original input stage. This is technical stuff, just in case you want to know. Was a I think those devices are about 1 nanovolt per hertz noise figure. And the one that's in there at the moment, it's a massive parallel hybrid, and we're down to about 0.3. So it's a factor of, God, if you actually did the inverse numbers on that, that would be a very, very, that's 399. Oh, God. We'll just call it something like nearly, I don't know, say 8 times less noise or something. That's internally generated. And I have done experiments with noise in detectors, internally generated, even the components. I think I've mentioned this the other day, that that noise does obscure signals. So that was the basis of a lot of mods on say 6,000 and 7,000 detectors. It can also be carried out in just about any electronic device that has a receiving front end. You can spend lots of dollars and get the noise down. That's how it works. There is a point of very limited returns doing that, but sometimes the difference, being able to hear something like a life-changing gold nugget and not hearing it, could be an absolute fly speck of a difference in noise figure. It's just how good your ears are and how good you can set your detector up, and just, you got everything working for you. That could be a big difference. So that's why we're getting these older detectors to give them the treatment. And the thing is that rather than giving them the whole treatment, really, it should be completely redesigned as a new detector. As a deep detector, a new redesign. Now, I mean, not just go and modernize it and put a micro in there to control it all. That's actually probably, to be honest, depends how things are done, putting microprocessors in metal detectors when you're trying to get things that are very, very deep and you don't want noise. A microprocessor can be a real thorn in your side in the design of electronics because the things make noise. And if you're using microprocessors, even for frequency control, if you look at these things, they generate, well, do I have to go and say all this? They generate tons of close-in phase noise and stuff. And, you know, they got jitter. They basically, you've got a frequency that's doing this. And it's actually, if you look at it very carefully, a lot of times it's doing this. I'm exaggerating how much it's doing it, but it sits there and it's like, ugh, and that stuff things up. That causes all sorts of issues. And a lot of stuff you just wouldn't know. You really need to go and expand out what you're looking at with a good oscilloscope, like my Tektronix there, or I've got that other thing, that 1.5 gig thing. The fan drives me crazy on that. Too noisy, so I only use it sometimes. There, the door opens. The door's closed. And yeah, you can see all this jitter if you move in on particular signals. So that's why I think, it's my opinion, that the first detector, as in the PI detector, the SD2000, was crystal controlled, and it wasn't basically, well, of course the base time, the time base is manipulated into different frequencies, but because it's a quartz crystal oscillator, it has very, very minimal sideband generation, phase noise, and it's just dead stable, right? Temperature affects it, but you can always ovenize that too, which I've done before on broadcast transmitters so they didn't drift, or else at the time it would have been, what do they call themselves here? They got a different name now, but yeah, it used to be a department of the PMG, Pigs, Meat and Gravy, we used to call them, Postmaster General's Department. Sounds like something out of the UK, doesn't it? But yeah, it was all to do with, you know, licensing, and you had to have things tested, it had to be dead stable, and you couldn't have your FM transmitter on a radio station go up the band a bit on a hot day and then go back down on a cold day, stuff like that, or the other way around, actually. So yeah, we used to ovenize it. We used to keep the crystals locked at, say, I don't know, whatever the hottest temperature was in the area. You know, so some of them we used to lock at 45 degrees Celsius, that is, and it would stay there until the temperature went up to 48. Then it would move a bit, but not that much. But if you had 48-degree temperatures, it'd be a bit of a worry. So no. Anyway, this gadget here, this has a super low noise front end, super low noise, and it's got variable gain in it too, because the guy's using this, as far as I know, with a really, really big drag coil, and wants to have lots of control over various aspects of the detector. And yeah, it should go really good. I don't know if you can actually see much of it there. It's probably got, well, at the moment I'm running it on that crossover coil, cancel coil, on the bed of ironstone there, because when you muck around with these old detectors, because there's manual ground balance on there, you have to twirl it and tune the ground. On low frequency and big coils, it really doesn't go out of tune. It's amazing. It's so broad, but if you get overground for smaller coil and that, you always got to ground balance the things. But on a big coil, and you're taking in so much ground as a big sample, you don't really need to. You sort of forget it after you set it. Set and forget, as they say. But the other thing with these too is that if you change the time-based frequency, the range on the ground balance circuits will stay basically the same. They're not tied in, and you could then have to shift the ground balance down. So what I actually do, I get the cancel coil here. I put it on a bed of horrible stuff, and then I take the horrible stuff away and just put it on standard Denali dirt or something like that, a big tub of it. And I change the scaling of the ground balance on channel 1 and channel 2 so that on normal Denali type dirt, it's basically in the middle. So any dirt that way or that way, you can tune it. And also I check it with hot rocks. And if you do want to check these things, I'll just show you this too, why not? I know some of you like mucking around with this stuff. If you do make a cancel coil like that, you got to remember these things, they don't act like a real normal coil. They're a bit funny, they're a bit reactive. And what you've got to take into account, that in here at the crossover point, it's really, really sensitive. And if you want to, say you get your, hot rock, and you want to make sure your ground balance is perfect, even if you're mucking around with your own detector, and you want to pull bits out and put bits in, when you do your ground balance, you want to go right at, put in channel 1 or channel 2, and you got the knobs, turn the knob to the corresponding channel all the way one way, and put a mark on the knob, because these pots are 10 turn. So 10 times around, they hit the other stop. 10 times that way, hit the other stop. And you get your little hot rock and you bang it right in the center there, and it'll scream like a banshee. It really will get upset, right? So what you do is turn your pot, count the turns until you can ground balance it. And you want to make sure that you got plenty of range. Maybe get that it's on 7 turns or something. That's okay, that's no problem. You're not going to find anything really hotter, and you got plenty of range the other way. But if you turn it and you can't ground balance it, well, you're not going to ground balance the ground very well, and you're going to have much range in one direction. So what you do then, you've got to go and rescale the resistors on the ground balance network, and do that for both channels, because they're both separate and adjust separately. They're both independent. So you can't just scale one, hope the other one will scale. It won't. You got to do both. You got to do channel 1 and channel 2. Channel 1 is the long pulse channel, and it's really forgiving to a degree with ground balance. And if you want to be really smart, right, if you've got a detector that has a low noise front end in it, and you've got variable gain, you can set it up and get the maximum out of it. On these detectors, well, there's a switch. I haven't got it connected in at the moment because it's out of the front panel. But you can get the switch and just flick it to channel 1, right? And it ignores channel 2. Channel 1 is very insensitive to small metal targets. This is where this design actually wins, and why a lot of people still like these detectors. So you flick it into channel 1, and you basically ground balance the whole detector, channel 2, channel 1, and then you go bang and flick channel 1 over, and it ignores, if you're using a big coil, it ignores things like, say, heads of bullets. It ignores lead shot, because it doesn't have because the off time on channel 1 puts out a huge long pulse, and the off time is really long, and all the small targets, the energy that it gets hit by the coil, they decay so quick, and they decay before the receiver turns on, so you don't hear them. But big targets, if you're after big stuff deep, like Coke can size nuggets, this thing will go deep. Depends how big the coil is and the configuration that you use. You can go really, really deep. Now, a lot of people will use a coil, a drag coil. They might use, I don't know, a 40-inch coil, 50, 60, 70, 80, 90, 100. We've done huge coils for people, but most people use them like so, right? And I'm going to tell you some tricks and little things that people probably don't know. This is great for farmers' paddocks. This is great for open spaces. Say you got your coil like so, okay? And what you're going to do, you're going to have the energy spread more or less out and then goes back into the thing. It looks like a magnet and iron filing sort of thing, but it's pulsing on and off. And what you can do is you can manipulate that coil shape, okay? So you get a great whopping coil and you want it to go deep. And say you're thinking to yourself, well, you know, this area had 100-ounce nuggets and all the rest of it. And because the whole thing's set up in a way that it goes really deep, and yeah, 100-ounce nuggets are going to ring like a bell probably, and anything else, welcome strangers and welcome nuggets and all those size things. You're not going to miss them in a fit. But the thing is, there's a lot of nuggets because gold's so damn expensive now. What about the deeper nuggets of 1 ounce, 2 ounce, 3 ounce, 10 ounce, stuff like that? And if you've got a great whopping big coil and the thing's down far, it may not saturate that target with enough energy from the coil to really energize it hard. So when the coil turns off, it goes like that, and the coil can now receive that signal. There's a way of doing it, but you have to do experiments with this because it does cause what we call field cancellation. When you start changing a coil like that and bring it in, you start losing performance. And if you want to go and completely crazy, basically like this, that's a coil, that's not a coil anymore, right? And everything else between to compromise. So you're going to get, if you run the two just fold the coil like that basically. So it's just a very narrow loop. Your detector probably will go coil over current anyway. It's not going to have any great amount of inductance, and it's not going to have any punch whatsoever. But within reason, now if you've got a really big coil, okay, and you're doing, you know, ground out here, say that big whatever. Now you bring the coil in and make it, say, a long, skinny coil. That would probably be getting close to where I would push the limits, and make it really long. But your field, if you understand this, instead of being like this, it's long and skinny, but it really goes deep, right? It really goes deep. And because you've crunched the field up and you've got closer intercept for these smaller targets, you'll be able to hear them. No one else has. Everyone else has gone over them, okay? So if you want to do experiments like that, you can. And even on a really big drag coil, these are all the big drag coils David makes. He's making them at the moment because we've got tons of orders of drag coils. So basically, you can flip it like this into a figure eight. But this is small, and it's, you know, it's only good for close-in gold. But the thing is, that automatically turns into a cancel coil. So any electrical interference coming in, hitting this coil and that coil, because it's flipped, it'll get, you know, your +1, -1, add them together equals 0. So you get 0 noise, really. Well, you've got to be perfect, but it's always a little bit iffy, and you can't get dead perfect because, you know, you've got a cable that connects to it, and you'll have probably different ground effects over the length of the coil, maybe a little bit. So it's probably 98% or something perfect if you can keep the shape. When you do that, and this is really good for low frequency detector work. That's why you can make a really, really big, huge coil, a massive one, because you've got to remember, when you turn to a crossover coil or a cancel coil, you could go pedantic and you could run a great big round transmit coil and have the figure eight on the receive channel as such. You can do that as well. That's basically a salt coil that was used in salt lakes. But why not use the figure eight to transmit as well? Why not? It works. We've tried it. It works really well. So rather than having two windings, you just get away with one. And because these things are flexible, we always say put them on with cable ties or use Velcro, and depending on conditions, just make a sled out of PVC tubing with a couple of upriggers on the front so it doesn't snag. And what you can do is you can say, okay, we're going to go around and make it a huge big mono. And we'll do that, and we'll go over the ground. And then you could say, well, let's crank up the gain like crazy because we've got a lot of atmospherics and noise, and we'll turn it into a figure eight and go over the ground again. And if there's anything that was hiding in the noise, you got a good chance of getting it. But this is where it gets interesting. You got to remember, as soon as you flip it into a shape like this, you're going to have a target's going to activate on this coil, and then it's going to activate on this coil. So it goes woo and then woo, right? And it might go high-low, actually, depending how things are configured, because you do have a phase inversion between the coils. So that sort of thing, if you find something and you go, oh, what coils it under? Well, the null in the middle of those two sounds is where the target is. It's in the null. So you just null it, It's in this coil. It's in this coil. Halfway in between, there, bang, that's where it is. So don't dig under the actual loops if you get a 2 signal from the coil, because you don't know what loop it was under, right? So always try and null it, like just move it across the target like so. Even use another detector with a 20-inch loop on it, come over and just, even you can just sniff it a little bit, you work out where it is. So, these, the same as the way the 7000 operates with its 3 coils, double blip, and in the middle, sort of null, and then you go, oh, that's where the target is, down there. A lot of people with those detectors, I'll tell you today, sort of dig off on the side here, and they can't find it, and then they dig there, but it's in the middle. And it was basically the same with a lot of VLF detectors in the early days, in the 80s, where people didn't do the ground balance properly. And what it would do, it's quite funny actually, when they go over a nugget, they have the whole thing tuned wrong with the ground discrimination. And as they went over the nugget, it would null, and then it would go woo, and they'd go the other way to go null, woo. And I used to see it out in the goldfields. You see a hole, and some people never fill their holes in. They dig here, right? So they've got a hole here, and you've got a hole here, right? And they can't find anything, give up. You just go straight in the middle and dig, right? And usually you find something in the middle of the 2 holes. So that's a good trick as well to keep up your sleeve if you see those sort of things. Don't go, oh, someone's been there and dug it, so I will ignore it. Don't ignore it, right? Because it was someone who didn't know how to set up their detector. It's very unlikely to get a nugget there and a nugget there, sort of that sort of spacing. When there's no more around, there's no more holes. It's just like that. It's that's the biggest hello. Come over here and check, right between the eyes, literally. So I have actually found gold by digging those sort of missed targets long time ago. But I don't know how many people have cottoned onto that. But maybe they have, maybe they haven't. So anyway, yeah. What else was there? I was just saying about, this is just about the swing back to deeper, bigger gold. Now, like I say, you got to remember, guys, you do have to remember that a lot of the big gold found early on by detectors with big coils and basic SD2000, I reckon the SD2000 found the most gold by weight of any detector in the bloody universe. There's so much big gold was found. Unbelievable. I went round to a fellow's house, probably going back 3 years ago, right? And I've gone round to a couple of people's houses and they bring out their gold and go, freaking put it in the bank, put it in a safety deposit box. Yeah, bring out, and they're going to show me their gold, and I'm going, oh, here we go. We're going to find some little half grammers and things. And one guy, I fell over backwards. One guy brought out gold, and I worked it out for him and said, you got about 200 grand of gold there. He went, what? I said, yes. Yeah. People don't realise, especially people who detected many, many, many years ago and just collected their nuggets and just kept them. And, back then, what was gold? $600 an ounce or something, or maybe even less. I don't know what it was. Can't remember. But what it wasn't what it's now, I'll tell you that. But they just kept their nuggets and, oh, yeah, look at the gold I found. They don't realise that it's gone up so much. It's gone up 10 times at least. So it's just the nature of the beast, isn't it? So you think you got a 10 grand nugget, sorry, it's worth 100 grand. And maybe more so because they're rarer and the collectors pay more for the gold. So this is why we're having a resurgence in old detectors, and people are trying to hunt up old SD2000s everywhere. Yeah, I know a guy at the moment. It's basically door knocking right through areas of Denali and Maryborough, asking if you've got any old metal detectors out in the back shed. He's trying to find the old 2000s. So they are becoming a bit of a collector's piece, because as a base detector, well, if you have a look at this thing, I have to undo it all. I haven't put the switches and things in yet. The other thing too, when you run these at low frequency, because the pulse is so damn long on the things, you can run higher inductance coils and get, within reason, get more turns into it, bigger antenna, more receive. Or you can run if you want to run split loops like a concentric, you can run more turns on the receive, right? But you've got to dampen it properly. I'll go into that another day. But you can get extreme depth on these detectors. Now, I actually fired this up on that Elite Max coil too, and it actually worked. It's a lot of noise, of course, but yeah, everything's going everywhere now. But if you have a look at this thing, you'll be gentle because it's all wires. So in the middle there, it has two stacks of low noise op amps and a variable gain board put into this as well. And you can see where the crystals are here. We just got one of the normal crystals, 1.8 megahertz, and that thing there is 1 megahertz on the knocker. It'd be good if it was a little bit off 1 megahertz because of 50 hertz harmonics being an even number. But someone, I don't know if they're here, someone brought me some crystals. Sorry, not in that bag. They're here somewhere. I haven't tried them yet. I hope they work, because there's all sorts of different types of crystals, and it's also different cuts of crystal, different sizes, and some that work on fundamental, some are overtone, some are third and fifth, seventh harmonics, usually odd harmonics, get more output. But I had some here, and 1.007 megahertz, but they're watch crystals. They're the size of watch crystals. 2 millimeters in diameter and probably about 5 millimeters long. Very small. And yeah, they were here. Hope they haven't blown away in the wind. I don't think so. It's funny, because yeah, that bag where the crystals came in, and I have to go searching now. Damn. I was just going to show these very small crystals. But yeah, you can, if you really want to get really smart and technical, you can probably put a, some type of variable frequency thing in there. They're within reason. Some of them are stable, some of them are jittery, and a lot of them have a lot of phase noise. Basically, if you look at it on a spectrum analyzer and you want to, look close in, you need a really good spectrum analyzer. I've got one here that'll do it. But you'll see the fundamental frequency like so, and it's nice and sharp with a crystal, right? And you may see a little bit of sidebands out here, and they just diminish. over a very small amount of spectrum, and you get these. Well, we're just going to call them VCOs. You can have all sorts of variable oscillators, not just a crystal-based variable oscillator with dividers and multipliers and how it's all put together. You look at the noise output of those, you look at your thing, and it looks like this, like that, all down the side. That gets into your receiver and screws things up. Makes life hard for what you're trying to do. It stops it being able to be made very, very low noise. It'll function. Everything will function. You can get an old bloody Russian Lada and stick it on the racetrack and you can drive around the racetrack. You're not going to win the race, but you can do it. It'll get from A to B, right? That's what we're saying. It's just, you can drive an old bucket of bolts anywhere if you wanted to. Same with what you do with the detectors. It depends how refined it is what you do. If you start off with a crappy time base and you start wanting to divide it down and do things, you start to multiplying up's worse, dividing down's not so bad, but you still end up with a lot of crap everywhere. It really is not the way to do it, even though people do it. If you've got a computer, yeah, great, you can do it with your computer. Who cares? You're not going to notice it. But don't do it with, nanovolt or microvolt level receiving equipment. What are you doing? You can open up any piece of electronic stuff and have a look at it and see how it derives its time base, or what its time base is, and then what it has to modify that fixed frequency to, usually a massive lot of division, mixing and multiplication, and all that function makes noise. So when, I might as well just put it out there like this, when MindLab, which I'd say with the 2000 Bruce Candy had a lot of input on, it's crystal controlled, and he killed the pig. It's crystal controlled. I know it's got a lot of other CMOS stuff of it, but the base, time base, is not it's not like put a 4 megahertz crystal in there and then derive it. It's it's this very small amount of division through some CMOS devices, and it comes out relatively clean, but it's a good way to go rather than trying to well, back in that day, you probably couldn't do it with micros. It would have had an 80880 in there or 4 megahertz or something, and it'd be noisy. But the base design is really clean. I've looked at the output, and it is clean. A lot of new stuff, you look at it and you say, it's sort of a bit wobbly. The other thing too, people probably don't realise that let me think. I've got to try. I'm thinking the circuit configurations in my head. If you look at the later detectors, like 21s, 22s, for a start, you have a look at those detectors, and even though they have some microprocessing there, it's done off its own time base and sits over in the corner and does all its jiggles over here. But if you want to look at the generation, the main timings for receiver and transmit, you'll be surprised. It's just LC oscillators, as in capacitors and an inductor. And that is also a very, very clean way of generating your time base for your transmitter and receiver. Not so much for the transmitter, but the receiver. Definitely, you don't want any phase jitter. So if you have a look at the later detectors, they use polypropylene, very temperature stable capacitors, and inductors that are probably normally embedded in a big layer of hot melt glue. It stops thermal shifts and keeps it stable. It's a good way to do it. And as soon as you look at all the detectors up, even the GPXs, the GPs, GPXs up to the 5000 are all LC time base for the receiver, transmitter, and all those specific timings. And I'm trying to remember about the 6,000, 7,000 after having a gawk at them. I didn't really need to go looking at the time base in them, but it possibly might be just derived out of the CPU. I don't know. I haven't really looked. I'm just guessing. I could pull one out of the drawer here and have a quick look. Oh no, I've moved it. Oh well, maybe. No, I moved it. I moved it. Now, just as a matter of interest, I'm interested myself now. What's the time base on them? Hang on a sec. Come here, you. Well, that's a 7,000, right? But that's not the bit we want to be looking at. We want to be looking at the other bit. This bit. I haven't checked this, but I think they're actually using a part of the circuitry. At a guess, I'm guessing, and this is my opinion, that there at the tip of my finger looks like an inductor, and the capacitor configuration around it looks like it's part of that inductor circuitry. I really need to get my 4-eyes on and have a really good look, because I'm just having a bit of an overview. But I can tell you if it's an LC oscillator, even in these late model detectors, that would be interesting, because I would have thought that they would be basically generated within the CPU. So let me have a look. Oh no, there's a crystal there. There's a little crystal oscillator sitting there, which is F25DOC. I don't know, it could be a 25 megahertz oscillator sitting right next to that capacitor there. And if I go next to it, I'm pretty sure that is a I'm pretty sure it's an inductor. But the way it's got some really nice looking high stability capacitors around it, connected to it in there. It could have an LC oscillator between my fingers, if you can see that. It's easy enough to probably poke it all out and measure it. But yeah, as you can see on this circuitry here, I've always wondered. I have mentioned this before, but if you look where my finger, just above my fingers, there's all these solder pads there. There's no components, so I don't know what was thought of to go there. It's not numbered in the silk screen, but there's a lot of stuff there is some stuff that is numbered, but like C203 there, that's a trimmer. It's a position for a trimmer capacitor, so some sort of frequency adjustment. And provision, I'm not joking. I'm just looking at this thing, and goes there, goes back there. Okay, right next to it, you see the above my finger tip, you can see two big pads. Well, that looks like position for another inductor, and there's position for capacitors and trimmer all the way around it. So maybe there was another transmit receive time base timing for these. And it's only my opinion, so don't crack it if it's wrong. But maybe there was a dual big gold, small gold setting. I don't know. I'm only guessing, but I can look at it and tell you a lot about it. Yes, it's got provision for op amps. Is something there which is a IC called U205. It was meant to be. It's not installed. Or, I'm not saying, oh no, they forgot to install it. No, they just didn't put it in this design. Maybe this is a base design for, different model. If you go, like I always said, if you look at the newer model 45 and the 5000, the circuit board's the same. The older circuit board for the 45 is a little bit different, but the base design is probably about 95% the same. So, and other stuff's done in software, of course, but with this, yeah, that's just a buffer amplifier, resistive divider. Yeah, so they look. Who knows? Maybe it comes out then. If this is just, God, they look like bloody something out of a science fiction movie wearing these. Maybe those components there were made. Were they for the GPX 8000? I don't know. I have no idea. I'm just saying it's provision for more stuff. What does it do? What was it intended to do? And why was it not included, or was it not important to include? These are the things, aren't they? But yeah, it is interesting. It is interesting. Like even over here near the power supplies, there's like provision for an IC there, and it's just got the solder lands for it. There's no IC. Oops, it's saying low battery. Damn. Yeah, tons and tons of test points, which I've actually gone and probed all those and looked at them, so I know when I do things on these detectors to just stop the extraneous noise whizzing around the circuit board, which it does a little bit because I've probed it and measured it, and I know how to drop the noise out of them. But there's just so much test points overall on it, and yeah, you can have a look at the back of the even the CPU. I don't know if you can see that. See those little capacitors? Everything there looks like a little ant. There's just tons and tons of capacitors, big ones here too on the main supplies. But that's just to knock out, in my opinion, all the switching noise from switching transitions of the micro. So it's relatively a good design. Looks like it's been developed by an RF engineer. Actually, it does. It looks like it's I don't know. It's just my opinion. Maybe MindLab got one of the engineers from Coden to come over and build it for him. But it does. It looks like it's been designed by an RF engineer. Very nice layout. Whoever did it. I don't know who did it, but very nice. Got some nice touches. Looks like someone who came out the school of Les Jenkins with all the gold flashing on the boards. I was a radio engineer from years ago. I used to always go around and visit him and stir him up. But he was a cantankerous old so-and-so. If anyone knew Les, I know people out there know who I'm talking about, but he was a cantankerous old bastard. But he's all right. But yeah, I should tell you. I should tell you about. Should I say? I got to. I got to. I've got to tell you this. It's bad, but it's so funny if you can understand. It's okay. Poor Les. He used to drink shandies, but if you took 12 bottles of beer around there, he'd mix it with lemonade, but the 12 bottles would be gone by the morning. Because we used to muck around with radio com stuff and muck around with all sorts of weird stuff at night. And a few of us would go around there, but he would drink all the beer, right? I'm being honest, he would. He'd drink all the beer. And that was the way to get in, bring a big carton of beer. And over the years, anybody who knew him, he had some businesses, and they say, you know why? What do you have? Oh God, I can't remember the ZBJ Electronics, some other businesses, and they'd all go broke, and people would it'd just be a running joke. They say, "Oh yeah, he drank all the profits," right? But at the end, his drinking caught up with him, and he got very, very sick, and he got so sick that he couldn't get it. He couldn't get out of bed himself. I had to go around there one day and help him get out of bed. He goes, "I've been stuck here for 14 hours." So anyway, not long after he passed away, and I went to his funeral. There's some stuff I can't say. I can't. It's just you wouldn't believe me if I said it. But I'll tell you one thing. It's funny. The fellow, I'm gonna say his name, Ian Jackson, also knew Les and went to his funeral. And Ian was sitting next to me, and they're showing all this stuff. Les was in the RAAF. He was a photographer and made films as well for the Air Force. And it's all pretty solemn, all sitting there, and they're saying all the things. And at the end of it, I can't believe this was actually said, because I'm going to crack up laughing if I say it, and I shouldn't, but it was so funny. Because we all knew that he drank a lot, right? And at the end of it, they said, "Look, after this service, we're having another get together at the Springvale Crematorium." And I sat there, and Ian Jackson, sitting next to me, turned to me and said in my ear, right, "I bet you he's going to burn with a blue flame," right? And I lost it. I lost it in the middle of the bloody funeral joint. Why say a thing like that? You know what reaction is going to have. Just the way he said it, the first thing I thought of was like a Bunsen burner. Oh dear. Anyway, maybe I shouldn't have said that, but it was funny at the time. And I think, yeah. Oh dear, it'll get around now because I said that, but it's funny. Yeah. Oh, he had another company. What was it? Tech Data. Tech Data was one of his companies. He was a really good engineer. My God, he was an engineer and a half, and taught me a lot of stuff in the early days. I used to go around there in my 20s, and taught me all about all sorts of radio equipment. And we were doing a lot of stuff with microwave back then. Really high gigahertz frequency transceivers and things. And internet 2.5 gig stuff didn't exist. We were using the Wi-Fi bands as our test bands. We used to do all sorts of stuff, satellite work, all sorts, and yeah, so it used to be good fun. Oh, that's right. He had another business. this is a good one he had. He started a business, and it was for crane operators. Now, listen to this. If you got walkie-talkies and you're going, yeah, up, high, low, you got a guy in the crane. You got an observer up there somewhere looking at the load, and you got a guy on the ground. And if anything goes wrong, they can't talk to each other all at once, because it's like this and that can talk and that can talk. And he developed this system. I'll tell you, it was quite good at the time. It was called triplex. And all he did is use a positive and negative IF offset. And everyone could hear each other. If one spoke, the other two could hear it. And it was like that all the way around. And it was a really good safety innovation. So if you know of anybody using systems out there where people talking and everyone else can hear it, it's because of the split IF thing, and intermediate frequency is part of the receiver. And basically they could all talk to each other, and it stopped a lot of accidents. Someone's yelling something out and these two are talking to each other from there to there, and or the crane driver's on the thing and they're trying to tell something from here to there to the crane driver. It doesn't go through, and load falls off and kills 25 people below. No, it's a good system. He invented that for memory. He did. He actually did. It might have been, I don't know, they called it triplex anyway. I've got lots and lots of stories about these people, but I don't want to, say anything about anyone who's still kicking. But yeah, he was a good fellow, actually. He was all right. But God, he put the bloody booze away. My God. Yeah, I reckon he had shares in the bloody brewery, the breweries. But yeah, old Jacko saying that in my ear, that was quite novel for the time and place. I'll never forget it. But that's the way it is. Anyway, this battery's going to go flat. I better kill it. And yeah, I was going to do the demo on that other Elite Max coil with the detector, full gain and everything. I have to get these detectors done for people, else I'm going to get my ass kicked. Anyway, catches.